All right, so let's go ahead and review 4.6, graphing rational functions. Let's go through it in detail, try to understand what we covered in class. And this is one of those functions that it would be nice for you to use Desmos to investigate, just to explore and understand why we're getting certain things. Here are my brief notes. We went in more detail in class, and I'll go over again really quick. How to graph, okay? So I gave this 3 steps, but if you want to create your own steps on how to, whatever is easy for you, how to graph. But whenever a radical function is given to me, the first thing I want to do is identify the h and k. I want to see what is the h value, which changes the function. It shifts the function left and right. That's the h value. And the k value shifts our function vertically up and down. So I need to see this h and k value. We always did opposite, opposite. So opposite, same. And we are going to say that for the rest of the unit here. Opposite for h and same for k. Okay, it has been the same for the previous unit. We've been identifying h and k. The reason why h and k is so important is because it marks the horizontal and the vertical asymptotes of our function. These asymptotes are imaginary lines that the function does not cross for specific reasons. And then after we identify this vertical and this horizontal asymptote, we identify the stretch of the function. So we use the stretch, and that is the a value. So if I was to write the general form of the function, f of x equals a over x minus h plus a k. So that is what the function looks like, and that's why we want to identify the h and the k value first, because that marks our horizontal and vertical asymptote. And then we want to identify the stretch of the function, which is this a value, and this a value, if it's positive, we count it up, and then we move 1 unit to the right. If this a value is negative, we move it down, and then we move 1 unit to the right as well. So as you can see, if it's positive, we go up. If it's negative, we go down, but we always move it to the right. So it's up, go up and right, or down and right. Okay, so that is the 2 moves we make depending of this a value. And then remember the reflection point. This is just to graph the first point, and then we have to graph the other side of the function, and I will show you how to do all this stuff. And then after we talked about this, after we talked about these 3 steps, we also talked about these important characteristics of the function, how to find the y-intercept. If I want to find the y-intercept, we plug in 0 for x, okay? That's how we find the y-intercept. Sometimes it's easy to see just by looking at the graph, but if it's not, you plug in 0 for x. If I want to find the x-intercept, I plug in 0 for y value, okay? That's how it helps me find the x-intercept. The domain, we decided, and we saw it through lots of patterns, that always comes from negative infinity up to the h value, and then it skips the horizontal, it skips the asymptote, and then it moves on with h all the way to positive infinity. So it has that, skipping that vertical asymptote at h value. The range, it behaves in a very similar manner. It comes from negative infinity, the negative lower y values, and then it comes and then it jumps at that k value, the asymptote, and then with the union of the k to the positive infinity. So it has to jump over that k value and that h value, okay? Then we see the vertical asymptote. Now the vertical asymptote is your h value. So it's x function, it's a vertical, x equals certain constant, and that constant, it will be your h value. Your horizontal asymptote is a horizontal line, so it's a y equals a certain constant, and that constant is your k value, okay? And then it always stays that way, and that's why that h and k is so important. As you can see, is used throughout our characteristics here of the function, important things of the function. And then we're going to talk about domains where it's increasing and decreasing, intervals, we always read it from left to right, the function left to right. And then we always use, you can use any notation you want, but it's easier to use interval notation with parentheses and brackets, okay? Whatever it's necessary to use there, okay? All right, so this is just a rough review of what we talked in class. Let's put all this into practice here with an example. So here's I have my f of x function. It is a rational function, and the first thing I'm going to identify is my h and my k value. That's the first thing I'm going to identify. Opposite of h, same as k. So opposite of a positive 3 is negative 3, same as k. I'm not adding or subtracting any k value, so that is 0. Okay? And then that is my very, very important point. Negative 3, so I go to negative 1, negative 2, negative 3, comma 0. It's right here. I'm going to put an open circle there because that is a very important value. And then I'm going to draw my vertical asymptote at negative 3. So that is my vertical asymptote. Okay, it's an imaginary line. And if you actually look at Desmos, this line doesn't even show. It's invisible. We're making it dotted so it can guide our graphing here. And then this negative 3 is here, comma 0, which is also here. So this is our vertical asymptote right here, which it happens to be the x-axis. So I already know that my function does not touch the x-axis. I will not have a x-intercept. And it does not touch this invisible asymptote of x equals 3 here. So now I need to finish graphing my function. Let me use a different color pen here if I can. Let's go ahead and identify the a value. The a value is our stretch. Okay? The a value is the numerator, and it happens to be a positive 1. Because it's positive, I'm going to move up 1 unit and then to the right 1 unit to create my very first point of the graph. So from this important asymptote value, I move up 1 over 1. So there is my very, very first point of the graph. But then I have to also, graph is reflection. I went up 1 over 1 to the right. To reflect that, I would have to go down 1 and left 1. So I would have to go over here, okay, to be able to create the reflection of that. We know the general shape of it. It is a curve that does not touch the asymptotes, and it goes forever. Same thing here is a curve that does not touch the asymptotes and goes on forever, okay, on both sides. And that is your radical, that's your rational function, the graph of your rational function. If you actually took time to plug in values for x and get values of y, you would find that this point exists, and many other fractions here, small values would exist, and all these points would exist, except you would never get the value of negative 3, comma 0. That's why it's a vertical asymptote and a horizontal asymptote here. Okay? So that's how you graph it. Pay attention to the stretch. If the stretch was negative, I would have moved 1 down, but I would still move to the right to create my first point, and then I would have done the reflection on the other side if it was negative. But it was a positive, so we're done. Now let's go ahead and answer all the questions we need here. I'm going to go to the obvious ones first, and I'll work on the harder ones after. Do I have a y-intercept? I sure do. It's right there. I see it. I just can't tell exactly what it is because it's a fraction. I will come and calculate it in a minute. I never touch the x-axis, so I don't have a x-intercept. So I'm going to write none. Okay? And then I also see that I have a vertical asymptote right here, this x equals 3 line. So x equals negative 3 is my vertical asymptote. My horizontal asymptote is this the x-axis, and the x-axis, students forget this, the x-axis is the y equals 0 line. Okay, so my horizontal asymptote is the y equals 0. As you can see, this is my h value, and 0 is my k value. So see how important it is, that h and k. Let me go back to the beginning. What is our y-intercept? Remember, for y-intercept, we plug in 0 for x. So that's exactly what I'm going to do. I'm going to come over here and plug in 0 for x. So I'm trying to find f of 0 for x. X is 0, which equals 1 over 0 plus 3. 0 plus 3 is just 3, so it equals 1/3. That's what that point is right there. So our y-intercept is 0 for x, 1/3 for y. That is our value of our y-intercept. We don't have an x-intercept because there's an asymptote right there on the x-axis. Our domain always comes from negative infinity. We read graphs from left to right, and that is the only direction we follow. We don't do it back and forth, we just do it one time. So my domain, I'm coming from negative infinity right here, from negative infinity. Then I keep coming and I get smaller and smaller value, but I never get close to the -3, so I put parentheses. I jump over the -3 and I get the super high values over here. So as the union, when I jump over, I create this union right here. And then I jump over the -3, and then I continue going toward the positive infinity, okay? Now let's look at our range. Our range, we are skinning the function up and down, okay? So our range comes from down here, negative infinity. Here's negative infinity on our graph. We're coming from over here, and we're coming from negative infinity, and then we come really close values up here, but we jump over the horizontal asymptote here, which is 0, and then we pick it up right from where we jump over, and we come over here with these values. So we jumped over the 0, and then we continue going up in y values really, really high. So we go to positive infinity up here. Okay? So it is really difficult for students to see this, but I first scan my values, the domain. I'm getting these domains, they're negative, and then I jump over the 3, and I continue get domains here. For the range, we look at the y values. I have y values for this function over here. But then we keep coming with y values, but then we jump over the 0 and we continue getting y values to positive infinity. We already answered our vertical asymptote. We already answered our horizontal asymptote. Now let's see if this function is increasing or decreasing. Well, over here, it looks like we have really, really small negative values. And then we keep on decreasing here in values, as you can see. As we are approaching high values on the x-axis, we are decreasing in y values. So it is a decreasing function. You jump over here at -2, you have a value of 1, but you're going to continue to decrease in values. You're going to get smaller and smaller fractions. So this function is decreasing from negative infinity all the way to our asymptote, which is -3, and then it picks it up from -3 and continue decreasing all the way to positive infinity. Okay? Oh, I'm sorry, it's not increasing, it's decreasing. That's what this function is, it's decreasing. This function is never increasing. Okay? So that's a rough example of what, how to graph it and how to evaluate domain, range, vertical asymptotes, horizontal asymptotes. Does it touch the x-intercept? Does it have an x-intercept? Does it have a y-intercept? All those questions we have to answer. So let's do one more, but let's do it right here on your paper. Okay, on your worksheet, question number 4. All right, so the first step is identify the h and the k. So opposite of +1 is -1, and same as k, -3. That marks my open circle, it marks the vertical and the horizontal asymptote. So -1 over here on the x, drop 1, 2, 3, so here we go. We have a vertical asymptote there. Let's draw our invisible vertical asymptote as well as our invisible horizontal asymptote right here. We are not touching these two imaginary linears here. If you want to go ahead and already answer that question, our vertical asymptote is at -1, so it is x equals -1. Oh, that is a horizontal. So here's the vertical asymptote. It is x equals -1. And then our horizontal is right here, the y equals -3. Y equals -3 line. Okay, so those are our vertical and horizontal asymptote. Okay, so let's go ahead and identify the stretch, because that's the next very important piece of information. A equals -1. That means I'm going to drop 1 unit and move to the right. So from here, I drop 1 unit and move it to the right. That is my very, very first point of my graph. The reflection of that will be directly across. So I dropped 1 and went over to the right. Now I'm going to go up 1 and 1 to the left. So here's my reflection of this point right here. Now I'm ready to draw the curve. We go really close to the asymptote, but we don't touch it. It's a nice smooth curve. And another smooth curve right here and right here. So it goes forever. That's why I like to put my little arrows at the end of things here to show me that I go forever. Okay? So that's what your graph looks like. We dropped 1 and we ran 1 to the right because of our stretch of -1. And then we made the reflection by going up 1 and 1 to the left. Okay, the graph is complete, and that's beautiful. Let's go ahead and answer a few questions. Do we have a y-intercept? Let's scan it. Let's look at visually, and then we'll do it by calculating. But visually, I can see that I am touching the y-axis at -2, 3, -4. So I already know that that's going to be 0 for x, -4 for y, without any calculation at all. Okay? Then the x-axis, I do touch it right here. And it's really, really impossible to tell. It is somewhere between -1 and -2. So my answer should be between -1 and -2. So let's go ahead and calculate it. You plug in, if you want to find your x-intercept, you plug in 0. Plug in 0 for the y value. Okay? So instead of j of x, I'm going to have 0. 0 equals -1 all over x plus 1 minus 3. Okay, I'm going to first add this 3. I don't have room for all the calculation. I'm going to write it right here. Okay, so instead of, I'm going to rewrite the function. Instead of j of x, I'm going to write y equals -1 all over x plus 1 minus a 3. Okay. Instead of y, I'm going to write a 0 equals -1 all over x plus 1 minus a 3. The first thing I'm going to do is add the 3 to the other side. Add the 3, add the 3. Because my goal is to get x all by itself. So -3 with +3 is 0, but now 0 plus 3 is 3 equals -1 all over x plus 1. If I multiply both sides by x plus 1, the x plus 1 here and the x plus 1 here are common factors, so they reduce. Over here we have a distributed property to use. So we do 3x plus 3 equals -1. Now it's just a simple algebra 1 equation. We can solve it. Subtract 3 from both sides, we get 3x equals -4. Then you divide it by 3, you get that x equals -4 over 3. And 3 goes inside of 4. 3 goes inside of 4 one time, so it's negative one time with a 1/3 left. Okay, so that's it. Let's go ahead. I knew it was something between -1 and -2. It's -1 and 1/3. That is our x-intercept after all this calculation. Okay. That is our x-intercept after all the calculation. We would show -1 and 1/3 comma 0, or if you want to stay with -4/3 comma 0, that's okay as well. So coming back over here to our question, our x-intercept is -4/3 comma 0, because we plugged in a 0 for y. Okay? And then state the domain. As you can see, we're coming from -infinity. There's a -5 that makes a point on this graph. There's a -6 that makes a point on the graph. So we're coming from -infinity. And then we have x values for all of these functions until we get to -1, but then we have to skip that -1. So -1 is not included. It marks our asymptote. And then we pick it up right from -1, and we have x values that will match our point in our function here. So from -1 all the way to positive infinity. Now let's take a look at our y values. As you can see, we have y values that is part of our function. So we are coming from -infinity all the way until we jump over this -3, which is not part of our function. We jump over. That's why we have this union and this jump over. And then we have a y value really close to -3 that is part of the function for this values over here in the function, and we go all the way to positive infinity. So you answer your y-intercept, your x-intercept, your domain, your range. We already talked about our vertical asymptote, which is this imaginary line here. We talked about our horizontal asymptote. Now it's asking, state the interval or intervals on which the graph is decreasing. As you can see, we're getting small, tiny little values here on the -5. But we are getting to -4, -3, -2, -1. Our function is increasing, right? Not decreasing. So there is no interval. There's no interval in where the function is ever decreasing. The function is getting higher values of y for each value as you move along from left to right on your domain here. Okay? So it keeps getting higher values of y. -2, -1. So it keeps getting higher and higher values of y on both of these graphs, on both sides. And then state the interval on which the graph is less than 0. I like to remind you that this means less than the y equals 0 line or the x-axis, okay? So if you look at the x-axis, that's where y equals 0 line. Where is the function less than? Well, from -infinity, the function, if you cover up this whole top of the function here, everything, the graph is below the y equals 0 line. Okay, here's the y equals 0. The graph is all below except between this point over here, the x-intercept, all the way to our little asymptote. That is the only portion of the graph, the domain here, that we see the graph above the line over there. Okay? So everything else from -infinity all the way until I get to this point, I am below the y equals 0 line. So I'm going to write from -infinity all the way to this -4/3, I am less than 0 here. Then I jump over that from -4/3, and then it goes all the way to positive infinity. The graph is below the y equals 0 line. So the only portion of this entire graph, both sides, that is above the y equals 0 is between -4/3 and our asymptote of -1. So that is the only portion that is above the, so that is, everything else is less than, okay? All right, so that should be able to help you. I know this question is very, very difficult to understand, but keep trying. If you show me that you know most of all of these, and this is the only thing that is bothering you, don't stress about so much, okay? Pick your battles, do the best you can on the other part of this graph. It's a lot of information for one graph, okay? For one type of function. So I hope this helped you, and please come and ask me for help. Good luck.